AI art can never be as good as human art. First, I'm going to show you what's actually going on with AI art. So what it's not doing is taking bits and pieces of existing artwork, like up here on the top and the bottom, and somehow mixing them together to create what you see. That's not how it works. Without just trusting me, it's obvious that's not how it works if you just mess around with it. Like, you can get really, really specific. Like, here I gave AI art the prompt poodle with rocket wings on top of a block of cheese. This is just so specific and weird of an image. This is not like patches from existing artwork. I mean, literally what it's doing is this diagram right here. But this is a bunch of Greek letters and colorful shapes. You know, it just looks like this, right? What's actually happening is it's given a prompt, right? Let's say colorful Greek letters. And to a computer, this is just a bunch of bytes. It looks like this. It's a bunch of numbers back to back that each number represents like what the character is. And this is not really workable, right? Because we're trying to get from this into an image. And in that sequence of numbers, it's just kind of arbitrary. And for technical reasons, it's hard for machine learning and AI in general to learn from those digits like 64, 25, back to back to back, to learn their semantic meaning, like what they actually mean, like what colorful means, what Greek means, what letters means, and how it relates to the rest of human concepts. And so the first thing that's done is the prompt is converted into something called latent space. That's probably an unfamiliar word for most people watching. What that actually means is it just takes this and turns it into a really, really big fixed set of numbers. Or sorry, it's pretty small actually. It's like around 100 numbers, floating point numbers like 0.5, 1.0, 2.0.2, and they just kind of represent the meaning of the prompt. And here's the key thing. The distance, like the distance between the points in this latent space, the distance between sets of numbers after this conversion means something. As in, the closer two numbers are together, the more kind of similar they are on a conceptual level. And this is learned automatically from millions of examples. So this is, if you were to take, so each of these are images, right? And they're being put into this latent space, which is just, it's a fancy way of saying it takes the data and it makes it very small. And in numbers where the distance between the small representation of numbers matters semantically or just means something, it represents something. And you can see here, right, all of the ones are kind of close together. All of the sevens are kind of close together. All the nines are close together, right? And what these clusters are is it's literally points in latent space. So this would be a latent space with two numbers, right? Like -5 and 2 is over here. Maybe -5 and like 5 is over here. You know what I mean? This would be -3 and 7. You get the idea. These are points in space. Some magic, this arrow is taking the input, which is just some text data, and putting it into a space where its representation is like the distance between other inputs means something. This is very, very critical for the next step. It makes it a lot easier because now you're not dealing with these arbitrary numbers before, the text data before. Now you're dealing with something that's kind of more tractable, right? So this magic machine, which converts these numbers into the latent space, is just one neural network. There's another one, right? This one, it's basically given random noise and this latent space, right? Some numbers which kind of describe in a location the qualities of something. With a point in space, it specifies how 7 is the prompt, or like how much like a horse is this prompt. And then iteratively over time, it turns this noise into the thing that you described. This diffusion network just learns how to make noise a little bit more conforming to the latent space of these numbers. And that's essentially the gist of it, the very rough gist, right? Now, here's what you have to understand. How do people make art, right? So we're just going to treat a person as a black box system for now, right? Because we don't really know how people make art, but we do know the inputs and the outputs of a person, right? They have their life experience, what they see, hear, taste, and touch, all of their sensory information combined for 20 years or whatever. This is the inputs, right? And then this neural network produces some kind of artwork. Now, this artwork depends on the information that the human was fed, right? Different people produce different art. If you look at most paintings, I would argue that there is at least 1 million individual things in this painting that only could have happened because of what Michelangelo's life experience was, right? Like, The fact that their fingers are almost touching kind of was because something happened to him when he was a kid, or this beard is because of some way because of something he did, right? And that million things, just when you look at this image, you kind of immediately perceive it all as your eyes navigate around the image. You see each of these millions of details, small samples of them, right? You go, oh, like, look at the shape of that guy's nose. Look at the shape of her curly hair. Look at the way this guy's hair kind of flows. There's just a ton of stuff. And if you're more of an expert, you see even more things. All of that information causes you to have some experience after viewing this artwork, right? If you want to duplicate the creation of that experience with AI, you need to have that level of meaningful detail, right? Meaningful detail creates the experience of viewing art, right? And meaningful detail comes from an extensive, huge amount of life experience. In other words, a huge amount of data, right? The problem with the stable diffusion architecture is the inputs are just, 5 million images from the internet. It's not a life experience, right? Now, AI art would easily be as good, if not better, than human art if it had this data in the right context, in the right architecture to understand this data. All of the life experience, all the words that were heard, like, no, you can't go outside, you're too short. All that stuff, you know what I mean? Combined into one big data set and trained, it could produce things with this meaning. I really believe that, right? But it doesn't. And not only that, but the prompt that you give it is not nearly as much information as goes into the creation of something like this art, right? Like, you could not recreate this picture with one sentence in all of its meaningful, detailed glory, right? The details are what adds up. Like, if you gave it the prompt, Adam lying down, barely touching fingers with God, who was surrounded by angels, this is the output, right? In order to actually recreate specifically this image, you would need documents and documents of detailed description of what it looks like and all the composition and all the notes and everything, the exact precise positioning of their fingers, right? The pose of their hands matters a lot, right? To your experience of looking at this painting. And you can see how little actual meaningful details there are in AI generated art. There's maybe 10 things, right? And the rest is kind of filled in with what makes the most statistical sense, which matches the actual architecture. And if you think that the little details don't matter in art, I encourage you to just peruse random paintings on DeviantArt, right? The reason why, so this looks astonishing and no hard feelings to the artist, right? It's very, very cool. And there's probably like 1,000 details in here, right? But just because the artist did not spend, 10 years painting something and studying stuff, because that input was not there, the meaningful details aren't there, so it doesn't feel as important when you look at it. Anyways, this is all I got for you guys today. My finals are almost over, so we're going to be back to Asterisk content soon. Don't forget to like and subscribe, hit that bell icon, and click the link in the description to play my game.